Today we will look at univariate data and measuring spread. This includes pie chart, bar chart, histogram, mean, median, mode, and standard deviation. We'll start off with what a frequency table is. A frequency table shows the number of individuals having each data value. So for example, this table down below, the preferred status, I guess life status, famous, we had 7 people respond. They wanted to be famous. Happy, 21, healthy, 3, and rich, 8. A relative frequency table shows the proportion or percent of individuals having that each data value. So what that means, instead of counts we would have in this column, they would be converted to percentages. And if we look at our example here, the American Association sponsors a web-based project that collects data about schools using surveys. 40 high school students were randomly selected and asked their preferred status. So this would be an example of a frequency table. If we wanted to find a relative frequency table, we would add all of our values together. So if we were to take our frequencies and add together, and this is pretty simple because it says we have 40 already, but we know that 7 over 40, that would give us the percent for famous. If we were to do 21 over 40, that would give us the percent for happy, etc. So now we can move into bar chart. A bar chart just shows each category as a bar. The heights of the bars show the category as counts or percentages. These are our steps to constructing a bar chart. Notice we're going to draw and label the axes, meaning we're going to put the name of the categorical variable under the horizontal axis. To the left of the vertical axis, we're going to indicate whether the graph shows a count or frequency or total or percent of values in each category. Then we'll scale those axes, meaning we'll write the names of the categories as on equally spaced intervals under the horizontal axis. On the vertical axis, you can start at 0 and place tick marks at equal intervals. And you will continue putting these tick marks here until you have the largest frequency or relative frequency. Then you'll draw the bars above the category names, make the bars equal in width, and leave gaps between them. Be sure that the height of each bar corresponds to the frequency or percent of those in the category. So if we look at another example, notice we have the students in Ms. Z's statistics class were recently asked if they would prefer a pasta party, pizza party, an ice cream party, or a donut party. And the data are summarized in our table. And if we wanted to construct a bar chart, this is what it would look like. A couple things that I'm looking for when you create a bar chart. You need to have a title. You need to have horizontal and vertical labels. Notice we also have a consistent scale on the vertical axis, and we have each of our categories roughly equal width for bar and approximately the right height for the count in the table. So if we go to answer the question, which type of party was most preferred, it should be obvious here that pasta was most preferred. And what percent of students preferred a pizza party? Well, we would have to take the pizza total divided by our total altogether. Okay, which in this case is 46, which gives us a percentage of 26%. When we start referring to a pie chart, it shows each category as a slice of the pie. The areas of the slices are proportional to the category frequencies or relative frequencies. Okay, so what that means is whatever percent is in that category is the percent of that area in the circle for the pie. Okay, so a population survey conducted by the U.S. Census Bureau collected data on the highest educational level achieved by United States 25 to 34-year-olds in 2014. And notice our pie chart describes the distribution. First of all, is the pie chart appropriate here? I would say it probably is. Now, the advanced degree and less than high school is a little difficult to decide which sector is really bigger, but I think it's overall okay. I mean, ideally you would want to have your labels in the specific sectors. Okay, which education level had the greatest percent? I'm going to go with some, put the wrong label in the wrong place. This one is some college, which is our greatest percent. Which education level had the fewest 25 to 34-year-olds? And to me, I would say the advanced degree. And that's it. When we start referring to a histogram shows each interval as a bar. The heights of those bars show the frequency or percentage of the values in that interval. These are the steps to constructing a histogram. The first thing you're going to do is you're going to choose equal width intervals that span the data. Okay, so ideally we would like to see at least 5 bars in a histogram. Now, if this were an assessment, I will tell you what interval size to go by on your histogram. Okay, then you would make a table that shows the counts or percent of data values in that interval. You'll draw the label and label those axes, meaning you'll put the name of the quantitative variable under the horizontal axis, and to the left of the vertical axis, you're going to indicate whether the graph shows a count or frequency or percent. Then you'll scale the axes. So whatever interval size you are going by on your histogram is how you will scale that horizontal axis. For example, if you had a scale of 2 starting at 0, each tick mark would be in increments of 2. So like 0, 2, 4, 6, 8. If you had increments of 4, 0, 4, 8, 12, 16, etc. And then you'll draw the bars. Now, histogram is different than that of a bar chart because the bars actually touch each other. So if we look at our next example, we are going to use intervals of size 20 starting at 260 to construct a histogram for the number of calories per serving for 16 brands of frozen pizza. Okay, so first thing I would do is I would obviously do a title, and we're going to say frozen pizza. Okay, and we know we're going to use intervals of size 20 beginning at 260. Put a little break in my graph and put a 260. And we are going by scale of 20. So that means my next tick mark is 280, and our largest value in the table looks to be about 380. So we will continue this until about 400. Okay, our vertical axis is going to be frequency. And it's probably okay to scale that one by ones. Okay, so remember we're talking about bigger than 260 but less than 280. So let's go through our table and count. I just see 1 260, so we'll draw that bar 1 high. Okay, if we go from 280 but less than 300, I don't see any. So we leave that bar blank, or it's almost like a gap. From 300 but less than 320, 1, 2, 3. Okay. Greater than 320 but less than 340. 1, 2, 3, 4. Okay. And then bigger than 340 but less than 360. 1, 2, 3, 4, 5. Okay, 360 but less than 380. 1, 2. And then what is left over is the single 380. And there's your histogram. In our next type of problem, notice that our histogram displays the resting heart rates of 26 ninth grade biology students. Notice our question, it says, what percent of these ninth graders have resting heart rates below 70 beats per minute? Well, below 70 would be here in our histogram. So we have to look and see how tall the bars are. So from 65 but less than 70 looks to be about 4 bars. 60 to about 65, 5 bars. If we have 55 to 60, that is 1 high, and 45 to 50, 1 high. So if we were to add those together, notice we would have 1 plus 1 plus 5 plus 4 over the total 26, 11 over 26. Okay, and then you would obviously divide that. And then if we look at the next question, it says what interval has the greatest number of students for beats per minute? Obviously you would have 70 minutes to less than 75 minutes, or this interval here. Let's talk about mean. Mean is the measure of center for a set of data. It is the average of the data. Whereas the median is the midpoint of the distribution such that half the observations are smaller than that value and half are larger. So remember what we did a long time ago. You would arrange the values from smallest to largest, and you would count until you get to the middle. If the number of data values is odd, the middle number is the median. However, if it is even, you have to average the two middle numbers to get the median. Mode is the data value that appears the most, and range is the difference between the maximum and minimum data values. So we're going to have some questions in which we have to find the mean, median, and mode and range of the height of these players or some team. So what you would do first, you would go into the calculator and you would find the STAT button, stat button, which is by the left arrow key. You will enter all of the data into list 1. If you have to clear it out, remember you make the L1 dark, push clear, then enter. And then you would type everything in. Once you get to that step, you are going to push the stat button, then calc, and then one variable stats. And you should get the following menu to appear. Now, the mean is denoted as the X with the line over it. Here's your mean. Okay. Your median is the one that's MED. Okay. Your mode, you would just have to look and count how often the most data value occurs. And then the range, you would have to take the maximum minus the minimum to get the range. Now, if you were using Desmos, you can do this in Desmos. You would select the table, type all values into X1, and then if you push the functions button and you go down to the statistics, you can do, I believe it's max X1 minus min X1, and that is going to give you your range. You can do the mean of X1, you can do the median of X1 also. When we start discussing standard deviation is going to measure the spread by looking at how far values are from their mean. We use with mean as a measure of center as the most common numerical description of a distribution. The standard deviation S should only be used when the mean is used as the measure of center, and we can use them in symmetric distributions. Note they will also have the same units as the mean. So if we're looking at dollars, your standard deviation is going to be in units of dollars. If we're looking at the unit of pounds, your standard deviation will be in the units of pounds. So here's just an illustration of where we're kind of shifting towards. This is what we call a normal bell curve. And the percentages, this 97 just means all of this underneath the curve to the left is 97%. The 84, everything to the left of 84 is 84%. When we talk about variance, this is just the square of the standard deviation. That's it. So when we start saying calculate the mean, the standard deviation, and the variance, I'm going to run the one variable stats like we did before. So we would type in all of these values here into our list one. We would push stat, and then calc one variable stats. And your standard deviation is this one that's the S with the X. And to find the variance, you would just square the standard deviation. If you were using Desmos, you would still bring up the table, but to get the standard deviation, you want to choose the one that says STDEB, and you can do the X1, and then that's how you would find that. Take a second and try this example you try. So hopefully for this one you find a mean of $3.61 per gallon, the standard deviation about 21 cents per gallon, and the variance around 0.043. And guess what? You're ready to do some practice. The end.